Alright guys, so what we're doing today is finishing up 731. So this is where we finished off yesterday, because we've done a few with factoring and simplifying, multiplying yesterday. So what we're doing today is kind of finishing it up. Now, whenever we multiply these two here, there's different ways we can do it. One of them is just multiplying it out, which is not going to be the most effective, and it's actually going to take more time. So the best thing to do with these rational expressions when multiplying them is to factor it first, then multiply, and then simplify. So the first thing we can do is factor each one of these here, factor the two denominators and two numerators. So if we look at the two numerators, two denominators, there is one of the four that is actually easy to factor. And that's 3x, because, well, it's just 3x. It really doesn't factor. There's no like terms. So it's just going to be 3x. Now the next easiest one is going to be the numerator of the first rational expression, our 3x minus 3x squared, because there's a greatest common factor of 3x, and we can factor it out of both terms. Because if we factor 3x out of 3x, we get 1 minus. If I factor 3x out of 3x squared, we're left with just x. Yeah. Because we did factor the 3 out. So we get this here. Now we need to decide if we're going to factor the x squared plus 4x minus 5 or the x squared plus x minus 20. Which one do we want to factor first? X squared plus x minus 20. We'll factor it first. So we'll have our two sets of parentheses because there's no greatest common factor. Since the 20 is negative, our signs are opposite. One's going to be positive, one is negative. Our factors of x squared are x and x. And the factors of 20 are 4 and 5, 5 and 4. And we can check this here. X times negative 4 would be negative 4x. 5 times x is going to be plus 5x, which will give us a positive x, the middle term we wanted. Questions on this so far? Now we can factor the denominator of the first one. Since there's no greatest common factor, we can have our two sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. The factors of x squared are x and x. 5 and 1. Which one should be positive? 5. Because if we want something to simplify out, we already have an x plus 5 on top. It'd be nice to have an x plus 5 on bottom for them to cancel. And if we check this here, x times negative 1 is negative x. 5 times x is going to be plus 5x, which does give us a positive 4x. Any questions on this here? Now we can multiply these together. So we multiply numerators with numerators, denominators with denominators. And normally I move the monomial terms. So in the numerator, that's just the 3x, the greatest common factor. I normally move it out front. We have 3x times 1 minus x times x plus 5 times x minus 4. The denominator. So again, I would move the 3x. I normally move it to the front. And it's being multiplied by x plus 5 and x minus 1. Any questions on this thus far? Now we can simplify anything that's being divided by itself, like terms on top and bottom. So one of them is and 3x. Those will simplify to 1. Anything else? So x plus 5 and x plus 5, yes. Now 1 minus x and x minus 1 are very close to each other, yes? But there is something interesting with those. Because in the numerator, the 1 is positive, and the denominator, the 1 is negative. In the numerator, the x is negative, but in the denominator, the x is positive. If the signs are completely flipped, what we can do is we can pick one. We can pick the numerator and factor out a negative 1 from it. Because if both terms, the signs are opposite, we can factor a negative out. Because in the numerator, if I factor a negative out of negative x, it becomes positive. And if we factor a negative out of the positive 1, it becomes negative 1. Essentially, I just switched both signs. That doesn't affect the x minus 4. Now are they the same? So if both signs are flipped, we can pull a negative out and get them to be the same. Because now they will cancel, leaving us with negative x minus 4. Questions on this here? Now, we look at the next one. Really, whenever we're factoring out a greatest common factor and the variable with the biggest exponent, so here it's squared, if it's negative, might as well take that negative out to begin with, because there's a chance it might come into play later. So for the first one here, 5x minus 5x squared, might as well go on and factor that negative out. Because we like making the variable with the biggest exponent, try to keep it positive. It's easier to work with. So here we can factor the negative out. Is there anything else we can factor out of our 5x minus 5x squared? The 5x. Now, I like keeping the variables in order from biggest to smallest. So I'd factor the negative 5 out of the negative 5x squared first. Negative 5 factors out completely. And if I factor an x out of x squared, we get positive 1x. So we're factoring and flipping it. Were you good with that? If we factor a 5x out of 5x, we get 1. But since we're pulling a negative out, it becomes minus 1. And this is a little bit nicer, especially compared to the last one, where we had 1 minus x, then had to factor the negative out and flip it. Why not do it at the beginning? We good with this so far? Yes? We ready to factor actually the one easier than that? Factor. Now we need to decide if we're going to factor x squared minus 4x plus 3 first, or x squared minus 5x plus 6. Or plus 3. Two sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and they match the sign of the middle term. Negative and negative. Our factors of x squared are 3 and 1. Now it's been brought up a few times. Well, we have the x minus 1 over x minus 1 already, yes? Can we go on and simplify it? Well, yeah, anything divided by itself is 1, yes? We don't necessarily have to wait to the end to say that these two simplify to 1. We can just simplify them now. Nothing that says we can't do that. So x and x, they are both negative 2 and 3. Since the 6 was positive, signs the same, match sign in the middle term, so negative and negative. Factors of x squared are x and x, 2 and 3. Now, looks like y'all probably already simplified it. Now, on the last one there, we rewrote it as one fraction, yes? Because we multiplied numerators with numerators, denominators with denominators. If you want to rewrite it and get it organized, that's perfectly fine. I end up doing this. Because again, it's going to become one fraction. Might as well just connect it instead of having to rewrite the entire thing back out. Now that we recognize that it is 1, what else will simplify? X minus 3 and 5x, which leaves us with Now, we can actually write it a different way. We can say negative x plus 2. Because I can distribute the negative through, we get the same answer. Dealer's choice on which one you want to leave it as, because they are the exact same thing. Questions on this so far? We like this so far? I think y'all are feeling comfortable with these here, yes? This isn't really anything different. We have a greatest common factor on top, difference of perfect squares. Not too much to speak of. Let's look at 24. Two reasons I want to do number 24. One is we do have some different ways that this is going to factor and work. And secondly, I've already done the other one twice today. I want to do this one. We didn't do this one in the other two classes. Now, the first thing I would start off is factoring. We're not going to try to factor everything, each one of them all at once, do everything all in one step, because for some of them, that'd be a little too much all at once. Now, one thing I do notice is that the numerator of the first rational expression is x cubed minus 27. X cubed is a perfect square. It's just x times x times x. Is 27 a perfect, not perfect square, perfect cube? Is 27 a perfect cube? 3 times 3 is 9, times 3 is 27. So we take the cubed root of 27, which is 3, and the cubed root of x to the third is x. So this is a different of perfect cubes. Well, different of perfect cubes, we're going to have a linear or kind of first degree term, 2 terms, and the other one's a quadratic. We end up getting x squared in the other one, yes? So there's a chance this here might be that quadratic term. And when we covered them the first time and covered them earlier this year, the quadratic that comes out of a difference or sum of perfect cubes does not factor. So if it does work out that this here is the quadratic part of x cubed minus 27, then it's not going to factor. Even if it did, if this matches up with the quadratic that comes out of it, we don't need to factor it, because if they are the same on top and bottom, they are canceled out, they're gone. So even if I could factor it, no reason to if they're already going to cancel out. So it's going to be good to start with this here, because it does work out that x, the quadratic that comes out of it, won't be factorable. And if x squared plus 3x plus 9 is that part, there's no point in wasting our time with trying to do it if it doesn't work. Now, we'll start out with this here. So it's going to be opposite, or same, opposite, always end on a positive note. Since we're starting out with a difference, so minus, the same, opposite would make it plus, always end on a positive note is plus. Now our first term is x, so we'd have x. Then our x squared, that first term squared is just going to be x squared. X to the first, and then no x term. Our second one is going to be 3, so we have x minus 3. We don't have anything in the first. In the middle, we'll have 3 times x, which is, and the last one's going to be 3 squared, and 3 squared is, x squared plus 3x plus 9. It matches up with that one there, yes? X squared plus 3x plus 9. Might as well just go on and put it back, because they match, so we can just stop there with that one. Nothing, I thought that looked like a 2.
No.
Yeah. So those match already, so we're good there. Now let's look at the denominator of the first. Is there a greatest common factor between these two? X squared. We can factor it out, which will leave us with x squared minus 9. That's kind of nice, because x squared minus 9 is the difference of perfect squares, yes? X squared is a perfect square. 9 is 3 and 3. So we'll be able to factor that here in a minute. Let's do greatest common factors first. The numerator, x to the fifth minus 6x to the fourth plus 9x cubed has a greatest common factor of x cubed. X squared is a common factor, but it's not the greatest. So we can take 3 x's out of each one, which will give us minus 6x plus 9. X minus 3, x squared plus 3x plus 9, x squared. So x squared minus 9 will factor 2, x minus 3 times x plus 3. This denominator is still x squared plus 3x plus 9. Here we have x cubed. So we need to factor the x squared minus 6x plus 9. Since the 9 is positive, our signs are the same and match the sign of the middle term. So minus and minus. X squared would be x and x. And the factors of 9 that we want are 3 and 3. So let's simplify what's in common. Well, the ones we already knew from the start, those quadratics. All right, then we also have x minus 3 with x minus 3. Yep. And that's it. Well, almost. X squared and x to the third. Because like basically subtract the exponent, so 2 minus, or 3 minus 2 is 1, and it'd be on top. And then we have x minus 3 squared. We could rewrite it as x minus 3 times x minus 3. Be the same thing over what? X plus 3. In the previous one, we did have a few more things cancel out, work out a little nicer, but there you have it. Any questions on this here? All right, we'll do one last one, and then we're actually done for today. I want to look at this one here. X squared plus 3x plus 9 does not have a denominator written. So what is it? 1. It's understood to be 1. I want to look at this because this here is a common mistake that does occur in that when we want to multiply it, I've seen it, is that we want to multiply this by not just the top, but also the bottom. It doesn't work that way. It only multiplies by the top because it's understood that the denominator is 1, so we're multiplying the x cubed minus 27 by 1. So if it's helpful to remind ourselves that it's 1, we can do that, or we can just multiply it with the top. Now, our numerator of the first, I'm going to say x plus 2, because there's no greatest common factor, and the degree is 1, so that is simplified as it gets. Now, the question is, will x squared plus 3x plus 9 factor? Maybe yes, maybe no. It's kind of hard to see at this point, yes? X cubed minus 27. Difference of perfect cubes, which x minus 3 times x squared plus 3x plus 9. It seems like we did that really fast, yes? We already just did that one, yes? X cubed minus 27, we got x minus 3 times x squared plus 3x plus 9. I didn't think we need to go through that one again. And since we do have it on top and bottom, these leaving us with x plus 2 over. And really a lot of this is just coming back to factoring. Factor them. Multiply numerators with numerators, denominators with denominators. Simplify what's in common on top and bottom. And there's your answer. Questions on any of this here? So that finishes up 7.31. We will do 7.32 Monday.